So for the first equation, we have HF plus H2O disassociates into H3O, or H plus, for the same thing, plus F minus. And the Ka is given as 7.2 times 10 to the negative fourth. So the first equation states hydrofluoric acid, HF, disassociates into water as represented by the equation above, given the equation. For question A, write the equilibrium constant expression for the dissociation of HF in water. So here's the given Ka. So you have Ka equals H plus and F minus over HF. So we get that by taking the H3O plus or H plus, they're the same thing, and F minus in the products and putting that on in the top. And then from the reactants we have HF and H2O, but you leave out H2O because it's a liquid. So what you're left with is H plus and F minus over HF. And that is the... For question B, we're supposed to calculate the molar concentration of H3O plus or H plus in a 0.4 molar HF solution. So here's the equation again, HF plus H3O, or H2O rather, giving H3O plus and F minus. So you use ice and you are given the 0.4 molar solution in the initial equation, and you don't have any of the products. So by doing ice, you're given 0.4 minus x and x and x. You neglect the x because of the 5% rule. So you take the Ka equation, plug in the 7.2 times 10 to the negative fourth, which was given to you in the initial equation, and then you plug in the rho of E into the Ka equation. So you're given 7.2 times 10 to the negative fourth, and then x squared over 0.4. Again, ignore this x because of the 5% rule. Solve for x, and with that you are given the molar concentration of H3O plus in this solution. So for question C, we're given HF plus OH minus gives H2O and F minus. So volume of a 15 milliliters of a 0.4 molar solution of NaOH is added to 25 milliliters of a 0.4 molar solution of HF. Assume that the volumes are additive. So, to calculate the number of moles of HF remaining in the solution, we calculate the initial moles of HF from the initial equation. So we multiply the 0.25 liters times 0.4 molar concentration to get the number of moles, and then subtract that from the number of moles of NaOH added, which is, we do by the same methods by multiplying 0.4 by 0.015 liters, and we are given 0.01 minus 0.06, so you end up with 0.04 moles of HF remaining. For question D, we're supposed to calculate the molar concentration of F minus in the solution. So the moles of F minus are going to be equal to the moles of NaOH added, which we calculated to be 0.06 in our previous question. So, to calculate the concentration, you take the 0.06 moles of F minus and divide that by the total volume of the solution, so that when you add it up, it's 0.06 over 0.04, and calculate it out to be 0.15 molar solution of F minus in our final solution. Question E, to calculate the pH of the solution, use the Henderson-Hasselbalch equation, so pKa plus log of F minus over HF. So you have the 0.04 moles of HF over 0.04 liters to calculate the molar concentration, the pH, and then plug that in. So you have the pH equals the negative log of the Ka, which is given to us in the very first equation, or question, plus the log of the 0.15 molar, which we calculated in question D, divided by the 0.1 molar concentration of HF, which we calculated just up here. And then solve, and you come out with the pH equaling 3.32.